2021, number 6. This is the AB exam. This is calculator inactive. We won't need it anyway. A medication is administered to a patient. The amount in milligrams of the medication in the patient at time t hours is modeled by this function and satisfies this differential equation. They did not give us the function, they gave us the derivative. At time t equals 0 hours, there are 0 milligrams of medication in the patient. Good to know. A portion of the slope field for this is given below. Sketch the solution curve through the point 0, 0. This is an easy one to get points for, and here it is. There we go. Don't cross that asymptote. That's it right there. That's part A. That was easy. Here goes. Part B. Using correct units, interpret the statement, limit as t approaches infinity, a of t equals 12 in the context of this problem. So here goes. Time to grab some paper. And 2021 AB exam number 6, part B. Using the correct units, interpret that statement. Okay, so as time increases, so as time goes towards infinity, the number of milligrams of medication in the patient, this is what we're dealing with. This is the quantity of medication measured in milligrams, and they do want us to use units, approaches 12. So basically as time goes on, we get closer and closer to 12 what? Milligrams. So I'm going to use that as a sentence. Write it in a sentence. As time increases, this is not the way it's worded in the scoring guidelines, which means we're wrong. No, I'm kidding. The amount of medication, you have to say the word milligrams in there, in the patient approaches 12 what? Milligrams. Okay, we're ready for part C. That was easy. Use separation of variables to find y equals a of t. The particular solution with an initial condition of a of 0 equals 0. That's not new information. They told us that. They said that at 0 hours there are 0 milligrams. So we are going to, well, separate our variables because they said so. 12 minus y over d, whoops, no d there, not yet. All right, let's separate some variables. Let's bring the y's to this side and the t's to the other side. So I recommend that we divide by 12 minus y, which will give us 12 minus y in the denominator, and then dt over 3. And we're going to integrate both sides. The easy part is going to be this one. That's going to be 1/3 t plus some value c. What we don't have here is the integral of that. So because this entire quantity is in the denominator, and we're taking the integral of it, it'd be 12 minus y. And for u substitution reasons, we need a negative in the front because the derivative of that would be negative. All right, that's what we have. I like to stop here and go ahead and find out what c is. There are others that would manipulate this and do all kinds of stuff. I really find it best. Stop right here, plug in 0, 0. So at 0, 0, we have negative natural log of 12. I could put parentheses on that because it won't be negative. And then 1/3 times 0 plus c. Because t is 0, y is 0. So c equals negative natural log of 12. And that's really all I can do with it. That doesn't really get me very far, but that's what I know about c. So I don't have a decimal on that. And again, I don't need to. I don't need to know the decimal. So the directions said to find y equals a of t, the exact functions, find the particular solution, meaning we had to find c. Otherwise, they would have said general solution. And what I need to do now is take this, which we found just a second ago, plus c. Well, now I know what c is. And we're going to solve it for y, so I think we can just go through this step by step. Let's go natural log of 12 minus y equals, and we'll change some signs. You don't have to do what I'm about to do, but I'm going to change the signs and turn it around. So natural log of 12 minus 1/3 t, or t over 3, same thing. And we're going to e both sides, so 12 minus y, it drops the bars. I am the one who drops bars. That's my rap stage name. That was funny in my head. Okay, subtract the 12, divide by -1. Feel free to do all that. I'm going to clean this up a little bit. This just looks nasty to me. So this is e to the ln 12 times e to the -1/3 t. There's your 12 minus t. Whoa, 12 minus y. Whoops. Okay. So the e to the ln 12 is going to give me 12, and then e to the negative 1/3 t. I'm going to start calling it t over 3 just because I want to. And let's go ahead and subtract 12. That's 12 right here, so negative that, and then y equals, that will be our function. And I'm going to turn it around again because we're changing the signs. You don't have to turn it around, but it's just a little thing I do. There we go. We have found the function, and that is indeed correct. Let's move on to part D, which I will not be able to do on the same page. So part D says something crazy. It's a lot. A different procedure is used to administer medication to a second patient. The amount in milligrams of medication in the second patient is modeled by this function. And we have y equals b of t satisfies this differential equation. At time t equals 1 hour, there are 2.5 milligrams of the medication in the second patient. Is the rate of change of the amount of medication in the second patient increasing or decreasing at time t equals 1? Give a reason for your answer. Okay, let's read it very carefully. The actual question is the rate of change of the amount of medication in the second patient. Okay, the rate of change would be this. This is the derivative of that function. Is that rate of change increasing or decreasing? Which means they need to know about the rate of change of the rate of change. That is a second derivative issue. So we're going to find the derivative of this. Let's go. So here goes. Part D, they told us that dy dt of this other function for this other patient in this other hospital in another town in another state with a different sickness. Anyway, this other differential equation is given to us here, and we're wanting to know the rate of change is increasing or decreasing. So again, we need the second derivative. So second derivative. First of all, the easy part, the derivative of 3 goes away, and then we're going to take the derivative of this. I'm going to take the negative with the y. Okay, so if it helps, you can just be like negative y and put a plus. Let's do that. There you go. So quotient rule. The derivative of negative y is negative 1 dy dt. There we go. And then minus negative y, and then the derivative of t plus 2, which is just 1. And then the denominator squared. There we go. Now, I want to know the actual value of the second derivative. Let me rephrase that. I need to know the sign of the second derivative at t equals 1. So let's keep going with this thing. What we're going to do is find the value of that second derivative at not just t equals 1, but technically it's at 1, 2.5, and I know that because I'm going to have to plug in some y's and some t's, right? So I'm using not just 1, but the 1, 2.5. So negative, something, dy dt, I don't know what that is. We'll come back to him later. And then 1 plus 2 plus 2.5 over 1 plus 2, all squared. Feel free to do as much of that in your head as you would like, because clearly we're going to have something over 9, and then we're going to have a 3 and a 2.5. We still haven't figured out this, though. So let's just kind of pause right here and find out what the dy dt would be at 1, 2.5, which should be pretty easy. I think I have some room up here. So dy dt evaluated at 1, 2.5 is 3 plus negative 2.5 over 1 plus 2. So we have 3 plus negative 2.5 over 3. And if you want to leave it like that, you can. I'm not. I'm going to keep going. Let's get a common denominator. That's going to give me 9/3 plus negative 2.5 over 3, which is going to give me 6.5 over 3. And originally, when I had worked this one out prior to the video, I had doubled the numerator and doubled the denominator because I just felt like it was going to make my life easier, which is totally legal. You're multiplying by 1 if you multiply numerator and denominator by the same thing, unless it's 0. And that's totally fine, but notice what's about to happen here. So there's that, and then grab your green pen and cancel. See, it kind of worked out that way. Sometimes they engineer the problems like that. So we have negative 6.5 plus 2.5. And that negative 6.5 plus 2.5 is going to give me negative 4, which is over 9, which is negative. That's all I really cared about anyway. And so let's answer the question. And I have to give a reason for my answer. So is the rate of change increasing or decreasing? Decreasing, because the second derivative is negative. And let's keep going. The rate of change of the amount of medication is decreasing. You're gonna have to tell why. Decreasing at that specific time because the second derivative 1, 2.5 is negative. Okay, and I was happy here. I'm going to keep going though, because when I looked at the scoring guidelines, I noticed that they went a little bit further for this, and they talked about continuity, which I think is a good idea. So I'm going to keep going with this. And the second derivative is continuous. So, like, if I'm going to have, if I'm going to be able to talk about whether or not something is increasing or decreasing at a point, I do need to have continuity to talk about differentiability. So originally when I worked this one out, again, I thought, okay, yeah, I've said what I need to say, but to be able to make that statement, I have to have continuity, and I do. So it's good to say that because the second derivative, which is staring me in the face right here, is continuous at t equals 1. Like t equals 1 does not create a discontinuity, so we're fine. So it is continuous in an interval containing t equals 1. And we talk about the fact that it's continuous in an interval because if I'm really going to be talking about something decreasing, I really need to be saying, look at this general area, and that's where that comes from. All right, let's score what we have. Here goes. Part A is really easy. Part A was only worth 1 point, and as long as you have this, then you're fine, and that is correct. It needs to touch at 0, 0, and generally be increasing in concave down, and approach the asymptote from below as t increases, and so the asymptote, the horizontal asymptote right here. All right, here we go, part B. We can get 1 point for part B, and it's just a sentence, and that sentence needed to include milligrams, of course, and it also needed to say the amount of medication in the patient. That's what they said, amount of medication in the patient. They probably would say amount of medication would work as well, but just medication in the patient is a little more specific. Be specific as you do these. All right, part C is worth 4 points, and so first of all, our separation of variables is worth a point, so we earned a point by getting that far. And we're gonna, let me get this piece of paper out of the way, it's kind of cluttering up my work here. The next one is gonna be the antiderivatives, so those antiderivatives will earn us a point. And then the constant of integration, where we use the initial condition, and then when we solve for y. So we just earned 4 points there, and a point there, and a point there, so that's 6 points total. We have part D to go. That should mean there are 3 more points to earn, and we're about to earn them using, first of all, the quotient rule. And then we determined that when we plug in 1, which also involves a 2.5, we get a number that is less than 0, so we got a negative there. And then the answer with the reason, and their reason does contain a discussion about continuity. So all this is also worth a point.